Ever wondered what's lurking in the shadows of the universe or how to peek into another dimension? In this video, we're embarking on an epic journey to CERN, the mastermind behind some of the biggest revelations in physics. We'll skim the surface of their scientific pursuits and what's cooking in their labs that are about to shake the very fabric of our understanding. CERN is more than just a bunch of labs. It's a crucible where mind-bending theories morph into reality. It's the birthplace of the World Wide Web, the web of knowledge, and cat videos that wraps our planet. Yet its contribution doesn't stop there. CERN also houses the Large Hadron Collider, LHC, the most extensive particle accelerator on Earth. Here, particles race at nearly the speed of light before smashing together, creating a kaleidoscope of tinier particles. This is where the Higgs boson, the elusive God particle, made its debut. It's the key to understanding why particles have mass. Thanks to CERN, this once-upon-a-time theoretical particle now holds a firm place in our scientific understanding. Now let's dive deeper into a thrilling, ghostly mystery, the world of neutrinos. If you haven't heard about these particles before, I don't blame you. These little fellas are so elusive, they're often called ghost particles. Despite being amongst the most abundant particles in the universe, they're virtually invisible to our instruments because they hardly interact with other matter. They can zip through a light year's thickness of lead in a second. In CERN's neutrino platform, nestled in a small town in France, two big boxes are on a quest to unlock the neutrino's secrets. They are part of the Proto-Dune experiment, and within their steel-clad walls, neutrinos are put under the spotlight. Through long baseline neutrino oscillation experiments, scientists are trying to understand how neutrinos change their flavor as they travel. Yeah, you heard it right. Neutrinos have flavors: electron, muon, and tau to be precise. And the weird part, a neutrino can change from one flavor to another as it zips through space, a phenomenon known as neutrino oscillation. If only there was some kind of ice cream oscillation. Imagine taking a bite of vanilla ice cream on a hot day, then the next second, it's chocolate. Scientists at CERN are investigating these oscillations to get a better understanding of the neutrino's mysterious behavior. So why would CERN scientists bother chasing something as elusive as a neutrino? Because these tiny particles might just hold the answers to some of the most profound questions about our universe, such as why our universe is composed mostly of matter and not antimatter. Just like that the quantum realm is bursting with new particles shaking up what we thought we knew. So what's been going on lately? Oh, just the discovery of a new kind of pentaquark and the first ever pair of tetraquarks. Hold on. I know what you're thinking. Penta what? Tetra who? I get it, the jargon is a bit of a mouthful. Imagine quarks as invisible Lego blocks, the tiniest particles we know of. Most of the time they come in packages of 3, making protons and neutrons. But now we're spotting these rebels, groups of 4 and 5 quarks all huddled together. These are our new friends, the tetraquarks and pentaquarks. But there's more. The LHC is also getting its moment in the spotlight with the discovery of a shiny new particle named XICC++. It's doubly charged and doubly charmed. It might not have a snappy name, but the XICC++ could be the missing piece in our understanding of the strong force. This is one of the fundamental forces of nature that holds quarks together inside protons and neutrons. It's basically the cosmic glue that keeps matter together. And just when you thought they'd maxed out on colliding particles, they're planning an upgrade so massive, it makes the LHC look like a science fair project. Meet the Future Circular Collider, or FCC. Not the most imaginative name, I know, but this thing is set to be the heavyweight champion of particle physics, a total game changer, the successor to the LHC. It's like LHC 2.0, or rather LHC on a gallon of Red Bull. The FCC is going to have a serious pair of wings. It's so much more than just the next generation of particle colliders. It's basically a time machine that takes us closer to the Big Bang than ever before. Now imagine a tunnel almost 100 kilometers long, neatly tucked between France and Switzerland. This colossal infrastructure is designed to hold not one but 2 particle accelerators. That's right, 2. And we're not just talking about upping the ante here. The FCC is going to dial up the energy by a factor of 8 compared to the LHC. And what do we hope to find with all this extra power? The FCC's main mission is to probe the physics beyond the standard model. That's the theory that describes all the known particles and forces, but leaves out dark matter and dark energy. The FCC could be our golden ticket to uncovering these cosmic enigmas. Not only that, but the FCC will serve as a testament to human ingenuity, reinforcing Europe's leading role in physics research and potentially offering breakthrough insights into the fundamental laws of the universe. And just when you thought CERN CERN was the only show in town, we now have a new contender stepping into the ring. Who could it possibly be? None other than China, with their ambitious plan to build the Circular Electron-Positron Collider, or CEPC, a mega collider that might just give the FCC a run for its money. You see, in the world of particle physics, much like in sports, healthy competition can be a good thing. It pushes us further, keeps us on our toes, and often leads to some pretty fantastic breakthroughs. And the CEPC, a mammoth collider with a whopping 100 kilometers circumference, is certainly set to shake things up. Imagine a ring so big, it would make the LHC look like a kiddie ride, with power 10 times that of the LHC. Talk about setting the bar high. So now, instead of one major player, we have two, and this raises a whole new set of questions. Do we really need two gigantic particle colliders? And will China be able to keep pace with CERN's FCC, given CERN's track record and vast experience? Or could this mark a shift in the balance of power in global particle physics? While these are all valid questions, it's also crucial to remember that science isn't a zero-sum game. Having multiple major colliders doesn't mean that one's a success and the other's a failure. It's more like having multiple eyes trained on the mysteries of the universe, increasing the chances of making breakthroughs. But hey, we can't forget why we're here in the first place. At the heart of all these marvelous machines and high-stakes competition lies an age-old quest, understanding the very fabric of the universe. Think about it. We're here on this tiny, pale blue dot, trying to make sense of all that's out there, from the smallest particle to the largest cosmic bodies. Even after discovering ghost particles, confirming the existence of the Higgs boson, and potentially unearthing a fifth force of nature, we've still got a ton of questions left unanswered. What was the universe like at its birth? Why is the universe's rate of expansion not constant? And, one of my personal favorites, are we living in a parallel dimension without even realizing it? And let's not even get started on the dark universe. That's a whole other can of cosmic worms. To find the answers, we need things like the LHC, HL, LHC, FCC, and even the CEPC. It's not just about building the biggest or most powerful collider, it's about using these incredible machines as windows into the mysteries of the cosmos, and hoping to catch a glimpse of the answers we're so desperately seeking. And to explore dark matter and dark energy, CERN is joining forces with the European Space Agency on the Euclid project, a mission dedicated to mapping the geometry of the dark universe. It's kind of like Google Maps for the cosmos, but way cooler. But don't take my word for it, we've got a whole video on the Euclid project that'll blow your socks off. It's packed with all the cool details about how CERN and ESA are trying to illuminate the darkest corners of the universe. So if you're interested in cosmic quests, you definitely don't want to miss it. That's all for now, space travelers. Until next time, keep your eyes on the stars and your mind open to the wonders of the universe. Over and out.